flows in the field, we can use two different data sets, two different satellite data sets. One is information that we get from weather satellites, so optical information within the optical range. The other one is from radar satellites. The advantage of radar satellites is that they can penetrate through clouds, and that's a big thing, big advantage, because in the Arctic is mostly cloud covered. So, however, during cloud-free days, one can use weather satellites, and I'm giving an example here. You can see here in the very top, in the northern section of the image, you can see the clouds and the shadow on the ice. But here in the southern part, one can see the individual floes. And I'll zoom in now. And in principle, on a cloud-free day, one could use this kind of satellite data to identify most suitable flow. Suitable flow for us is, for instance, a rather round flow, simply because it has a reduced tendency to break apart, while others, like this one here, with lots of edges and so on, breaks apart more easily. Under a cloud cover situation, we use radar images. So let me show you an example. So this is a good example. So, well, actually it also shows the MOSAiC flow itself. I will zoom in now and show you the MOSAiC flow. Here it is. This sort of, and I zoom in closer here, this sort of diamond-shaped flow is where the MOSAiC experiment has been set up. So, and so in order to do a proper interpretation of these images, you need to know how it works. So basically, the satellite emits a pulse, and then the pulse is reflected back it penetrates through the clouds, and it's reflected back from the surface. And the amount of energy which is reflected back depends upon the surface roughness. So a very rough surface will probably reflect most of the energy back. That means that this will be displayed here in white colors or brighter colors, and a rather smooth surface, the energy is reflected away from the sensor, and this will appear rather dark in an image. So you can see here the MOSAiC flow, and there is this sort of a very bright center, and that basically means that there is an area that is sort of highly deformed with a very rough surface. And that's kind of a cool thing, because given the sea ice situation right now, this is where they are planning to put more heavy stuff on. So that's pretty thick, with 4 to 5 meters and so on. The area, this is just north and south here, is a little darker, or it's a little darker. And this is rather level and smooth ice. You find lots of these flows with a similar appearance in the vicinity. I zoom out now a little bit. And you see here are more flows that have kind of a similar appearance. They were all formed at the same time. They're rather level, still thicker than the surrounding, but were found to be less suitable. All the area here around the flow, sort of this wet grayish color, corresponds to either very old ice that is completely rotten and soft, or newly formed ice. So what we were doing during the MOSAiC experiment is to identify these sort of darker flows that are suitable to host an instrument for a given time, and of course to identify the MOSAiC flow itself.